How are you, my students?
I'm fine.
Today we are going to learn more about calculus, that is second order derivatives. So we are at this point now, that is given e power xy is equal to sine x. Show that d squared y out of dx squared plus 2dy out of dx plus 2y is equal to 0. Given a question like this, so we can simply find a solution to the same. We can be able to say that here we can use the product rule. So the solution to this, we can be able to use the product rule here. The product rule, that is, we are differentiating now d out of dx of exy must be able to give us the sign of x. Remember this one, differentiate this one now, we hold one and then we differentiate the other one. So like this one, we can simply hold ex. Actually, we are supposed to differentiate even the sign x, because we are showing that that one is equal, will give us this, differentiating 2 times. So d dx into sine x. Yes. Now differentiate this one, we know that this ex, you hold one and then you differentiate the other one, then d out of dx of y, then plus y, then d out of dx of ex. Then of course differentiating sign, we know that we simply obtain cos x. So this one is differentiating this one, we simply obtain ex dy dx, then plus y, then differentiate the ex. X is a constant, so it is simply that constant, ex is equal to cos x. So up to this point, we can be able to say that we have been able to differentiate 1 times. So let us differentiate it the second time. Let us differentiate this the second time. So it will be d out of dx of ex, then dy out of dx, then plus d dx of y ex, then d dx of cos x. Yes. So then now we are doing this one. Now differentiating this one, that we said we hold ex the first time, that is the first attempt. Let us hold ex, then let us differentiate the dy dx, dy dx, then plus, let us now hold the dy dx, dy dx. Then we will be able to now differentiate. We now differentiate the ex, and so we also differentiate cos x. We know that we'll be able to obtain a negative sine x. Negative sine x. So let us, when we come here, we are not reading this one. There was also another one here. So then plus, let us hold y, then d out of dx of ex, then let us now hold ex plus ex e power x, then now differentiate the y, d out of dx of y, then is equal to differentiate cos is negative sine x. Then now let us differentiate it. So it is of course ex, and then d dx of dy out of dx, which is simply a multiplication, so we're able to obtain d squared y, d squared y out of dx times dx is dx squared. So we are done with that one. And then we go to the next one. It is dy dx. Then differentiating a constant, we remain with it. The constant does not change. And then plus y. Then differentiating again the constant, so it remains. That is ex, and then plus the constant is here, it is already out, so, and then differentiating now y, we're able to obtain dy out of dx is equal to 2, 3, 4, 1, 2, 3, 4, we are okay. Sin x, but now remember, instead of sin x, we add e power x y, so but there is a negative, so negative e power x y. So we are now there, we are here, so we can be able to realize that ex appears everywhere, and therefore we can be able to factor it out. So this simply factoring out, and then you will be able to cancel it. So this one, this ex, this one, and this one will be able to cancel out, and then now you remain with d squared dy out of dx squared plus dy out of dx plus y, then dy out of dx, then minus y, and then let us combine that one together, and therefore we can be able to see that the answer remains as d squared y out of dx squared, and therefore dy out of dx, it appears twice, so it is 2 dy out of dx, so plus 2 dy out of dx, and we are almost done. And then lastly, there is this y, and then after the equal signs we have negative y, so bringing the negative y inside, and therefore we're able to obtain y plus the y we have already brought inside inside the other numbers, and then we're able to obtain plus 2y, and then what remains after the equal signs is simply 0. So up to this point we can be able to say that we have finished, because we have shown that differentiate this one, that is higher order derivatives, differentiating this one 2 times, we're able to obtain this, and therefore up to that we say that the question is done. Thank you much for watching. Please subscribe.